Our group's role is to analyze the gel that was produced through SDS page with Kamasi blue staining. This is the gel with lanes 1 through 10. Lane 1 is the marker, lane 2 is the cleared lysate, lane 3 is the flow-through, which contains fraction 6, and lanes 4 through 10 correspond to fractions 19 through 24. In lanes 2 and 3, it looks like there could potentially be a band for MGH protein, but it is difficult to tell due to the large amount of protein in the lanes. This shows the purification method was very effective in separating MGH from contaminating proteins and having the proteins flow through without binding to the column. Lane 4 is a sample of authentic MGH, which can be used to compare to what we got in lanes 5 through 10. Lanes 5 through 10 also have a large band in the MGH area, meaning they all have MGH in them. There are no signs of degradation, but if there was, a way the purification method could be improved is to increase the amount of PMSF to inhibit bacterial proteases from degrading MGH. While EDTA could be utilized to the same effect, we can't use EDTA because we did nickel NTA affinity chromatography. The EDTA would chelate the nickel in the column and leave no nickel available for the his tag on the MGH to bind to, meaning that no protein could stick to the column. In lanes 5 through 10, there are minimal signs of contaminants, and the bands representing MGH are relatively large. However, we could increase the size of the bands by adjusting how the cells were initially cultured before the purification process. We could increase the volume of the cells or allow the cells to grow more to increase cell density. The preferred method is to increase the volume of cells, as allowing the cell density to become too high runs the risk of cell overexpression inhibition. We could also increase the temperature to encourage cell activity. However, protein behavior is unpredictable at higher temperatures, and proteins could be produced in inclusion bodies, which is why we initially overexpressed at lower temperatures. An alternate method we could use is the modulation of IPTG concentration to increase the signal for cells to overexpress MGH. However, it is unknown to us how varying the IPTG concentrations affects overexpression efficiency.
The FPLC team recommended fractions 2 through 9 and fractions 17 through 23 because they saw the blue line representing protein concentration rise on the FPLC trace. During FPLC, buffer A passed through the column and took the contaminants with it, while MGH stayed bound to the column. The contaminants then passed through the spectrophotometer, which is where you can see the blue line increase from fraction 2 through fraction 9. Later, with the addition of buffer B, MGH let go of the column and then passed through the spectrophotometer, which is why you can see the protein concentration increase from fraction 17 through fractions 23. The FPLC team recommended fractions 2 through fraction 9 because they saw protein in that area, and the spectroscopy team confirmed the presence of protein while also concluding fractions 4 through 8 was where the majority of contaminants resided. Although we are more interested in the MGH yield, we put fraction 6 in our gel to study how many contaminants were separated during the purification process, as well as confirm whether any MGH was in the contaminants. Going back to lanes 2 and 3, it is difficult to discern any bands in the cleared lysate, and there were several bands of protein that are present in the flow-through. Although there might be a small amount of MGH in the cleared lysate and flow-through, the density of contaminants present in both lanes shows most proteins in those fractions were contaminants. For the MGH protein, the FPLC team recommended pulling fractions 17 through 23, and the spectroscopy team only adjusted the range slightly by recommending pulling fractions 19 through 24. We agree with the spectroscopy team, as fractions 19 through 24 give the optimal ratio of purity to yield, shown by the bands in lanes 5 through 10, which not only have noticeable bands in the MGH area, but also minimal to no bands anywhere else.